In this tutorial, I'm going to show a couple of examples of how the method of elimination works. It's an algebraic method for solving a system of linear equations. So we're going to take a look at two examples. And what you're doing in elimination is you're adding or subtracting multiples of equations to eliminate a variable. We've got two variables here, x and y, so the first thing you have to do is choose, am I going to eliminate x or am I going to eliminate y? After I do each example, I'm going to show you graphically using an online graphing utility called Desmos what you're actually doing to the equations, what it looks like graphically as you solve them. So I'll do that for each one so you can see why this actually works. So in the first one here, I'm going to it's a good idea to label them, so I'm going to call this one equation 1, this one equation 2. And I'm going to eliminate x. I could do y. I could do it just as easily. Sometimes one variable is a little bit easier to eliminate than the other, but it often doesn't matter. So I've got 2x and 3x here. So the first thing you have to do now is think of what's the smallest number that 2 and 3 both divide into. If I were to write the multiples of 2 down, they'd be 2, 4, 6, 8, 10, etc. So there's the first 5 multiples. The multiples of 3 are 3, 6, 9, 12, etc. And see, the first number that's in both lists is the 6. That's why 6 is called the least common multiple. It's the smallest multiple they have in common. Okay, so that's why I'm using 6 here. So what I want to do now is multiply each equation by a number so that this is going to become a 6x and this is going to become a 6x. So here's my first and second equation. So I'm going to multiply that one by 3. That would make that a 6x. That's 3 multiplied. That's not an x there. And then I'm going to take the second one and I multiply it by 2 because that'll make that a 6x. So I'm going to multiply by 2. So when I actually do the multiplying, 3 times this would be 6x, 3 times negative 5y is minus 15y, and 3 times this 3 is 9. So now we're going to multiply the second equation by 2. So all these by 2, so that'll be 6x. That 4y times 2 is 8y, and that 16 times 2 is 32. And then put a line underneath them. And sometimes you add, sometimes you subtract. We're going to take a look at one example of each here in these two examples. So what you do now is say, well, I'm eliminating the x's. Okay, at both 6x terms the same. So do I subtract or do I add? And you see 6x minus 6x is no x's. That's the eliminating. So I'm going to subtract here. And I'll talk about what adding would look like here and why you wouldn't do it then after I do this. So 6x minus 6x is no x's. Now you could write 0x here if you wanted to, but because there's no x's, we just leave that blank. So negative 15y minus 8y, same as negative 15 plus negative 8, would be negative 23y, and 9 minus 32 is negative 23. So I'm trying to isolate, I'm trying to solve for y here, so I eliminate x's, so that now I'm gonna find y. And by the way, if you added instead of subtracting here, see 6x plus 6x would be 12x, there would be an x term there still. And if I added negative 15y and 8y, there'd be a minus 7y here, so I wouldn't have eliminated the y. And then it would equal, if I added 9 and 32, I had to 41, so it would equal 41 here. So I wouldn't have eliminated. When the two terms are the same, they subtract to 0. Okay, if they're both the same positive number or both the same negative number, then you get 0 when you do that subtracting. So to isolate for y now, I'm going to divide out this negative 23, so y works out to be positive 1. Now that I have y is 1, we're going to substitute 1 here or here, and it doesn't matter which equation you use. So I'm going to use the first one here, the 2x minus 5y equals 3, 1. So we're going to put 1 right here. And so 5 times 1 is 5, so this is a minus 5 after the 2x. Now, I'm trying to find x now, so I want to isolate the 2x term. So you see, this is a subtract 5 here, so I'm going to add both 5 to both sides to get rid of that 5, the minus 5 on the left. So that's going to be 0, so 2x would equal 8. And then we would divide out the 2 here. See, 2x is 8, so I want to know what x is, so we'll divide out the 2. And so we get x is 4. So there's our solution. Now you should always check, and then I'm going to show you the graphical thing. So check and make sure that it's the right answer. So in the two equations, the 2x minus 5y equals 3, 1, that's the left side expression, 2x minus 5y. So I'm going to put 4 in place of x here and the 1 in place of y. And if it works out to equal what's on the right, then it checks. So let's put that 4 here and 1 here. So 2 times 4 is 8. That's 8 minus 5 works out to equal 3. And you see 3 is what's on the right side, so the left side and right sides work out to have the same value when we put the 4 for x and 1 for y. So that's why it's said to check or satisfy the equation. So let's do the same thing in the second one. The 3x plus 4y equals 16, 1. That's the expression on the left side. So again, 4 is going to go here, and the 1 for y is going to go there. So 3 times 4 plus 4 times 1. So that's 12 plus 4 works out to be 16. And 16 is what's on the right side, so it checks in that one as well. So we would know then that x is 4 and y is 1. So let's bring this up here. Okay, so there's the same system of equations. Just to compare, you can look, see they are the same. Okay, so the first thing that we did, if you remember, is I multiplied this one by 3 and this one by 2. So if I multiply that by 3, remember that gave me 6x minus 15y equals 9. And so notice that this equation coincides exactly with that one. See, taking a multiple of an equation gives you the same line. It doesn't change it. It's just like a bigger multiple. It's still the same line. And then we multiplied this equation by 2. So 3x times 2 was 6x plus, and that was, whoops, plus 8y equals 30, and then remember it was 2. And so you see that line coincides exactly with that one. They are the same lines. And so remember we subtracted them, so let's put another one down here. So 6x minus 6x was no x's. Negative 15y minus 8y was negative 23y, so negative 23y equals, and 9 minus 32 is negative 23. Okay, so this line here, oh, by the way, there's the solution for, remember it was x is 4, y is 1. This is the line y equals 1. And actually what I could do is if I divide that by negative 23, I get y. And divide that by negative 23, it equals 1. So there's my solution, y equals 1. Okay, so, and then we could actually, remember I substituted the 1 in place of y here to solve for x. Remember, so remember x is we think that x is 4 here. Remember, x is 4. So let's take that first equation, and I'm going to put 2x minus 5 times 1 equals 3. Okay, so notice what that gave me is a line. See, every time I do a line, one of these new multiple lines here, I'm getting a new line that still goes through exactly the same point. Okay, so when I added these two multiples, that negative 23y equals negative 23, that was this line. It still goes through exactly the same point. And so this one here, so remember what I did to solve for x is I added 5 to both sides. And so on the left, that would just give me 2x. And that was equal to, and remember 3 plus 5 was 8 over here. Okay, so again, same line here. And if I divide 2 out of both sides, I get x equals 4. So there's my solution, x is 4. So that's what you're doing, what it looks like graphically when you're doing the method of elimination. So every time you take a multiple of a full equation, you actually get the same line. And when you add or subtract multiples, you get a different line, but it still goes to the same point. See, every single line here goes to the point 4, 1. So our solution, my solution is 4, 1. So let's get rid of all these, because we'll need this again in a moment. Okay. So let's go on to the second example. So 4x plus y equals 10. 5x minus 2y equals 19. So I said I would do one example of an adding and one of subtracting. Now when you have one of your variables has a coefficient of 1 or negative 1, then you can do a little bit shorter or quicker elimination. So again, I'm going to call this equation 1 and 2 here. So I could choose to eliminate the x's. I can multiply that one by 5 and that one by 4, and they both be 20 x's. But I'm going to actually I'm going to multiply this by 2, because then I'll have a 2y here and a negative 2y here. They don't have to be the same. They can be opposites too, because opposites is when you add, actually. So first equation is going to get multiplied by 2. So if I multiply that by 2, that'll be 8x. 2 times that's 2y. 2 times 10 is 20. And I'm not doing anything in the second equation because, see, it has the opposite term to this. So when you see that coefficient of 1 or negative 1, this is a little quicker way to do the elimination because I only have to multiply one of them by a number. And so these are opposites. Opposites add to 0, so that's why we're adding in this case. 8x and 5x is 13x, and 20 and 19 add to 39. There's no y term here because those two y terms add to 0y. So I want to isolate for x. I want to solve for x, so I divide out this 13. And so that divides out to give me x equals, and this is 3. So x is 3. So now let's take our 3 and either put it in place of x here or here. It doesn't really matter which one. I'm going to use the first equation. So I'm going to use the 4x plus y equals 10 one. So I'm going to put 3 right here. And 4 times 3 is 12. So in order to get rid of that 12 that's added to the y, I'm going to subtract 12 from both sides. So that's that 12. I'm subtracting 12 from both sides. That adds to 0, so I just get y on the left, and 10 minus 12 is negative 2. So negative 2 is my solution for y. X is 3, y is negative 2. Let's do the check, and then we'll look at the graphical, the way of doing this as well. So here's my check. Left side expression of this one is the 4x plus y. So I'm going to put my 3 here and my negative 2 here. And so 12 minus 2 is 10, and that is what is on the right side, so that checks. And then the 5x minus 2y, 1. Again, 3 for x, negative 2 for y here. So that's 15. Now, subtracting minus 2 times negative 2, there's 2 negatives there, so that'll be a plus 4. So 15 and 4 do add to 19, what's on the right side, so it checks. So the solution is x is 3, y is negative 2. Okay, let's bring Desmos back here again. And let's type in the two equations. 4x plus y equals 10, and 5x minus 2y equals 19. And so the first thing that we did was we multiplied, we're going to eliminate the y. So we multiplied that equation by 2. And actually, let's just look at the solution here. Remember the solution was 3, negative 2. There's the 3, negative 2 point. X is 3, y is negative 2. So let's multiply this equation by 2 like we did in the solution. So the 4x would multiply by 2 to give you 8x plus 2y would equal 20. So notice that, again, multiplying that line by 2 gives you the same line. So now what we're going to do is we're going to add these. Remember, we added the two opposite y terms. So 5x and 8x add to the 13x, and 19 and 20 added to 39. So equals 39. And so again, there we produce a line that still goes through the 3, negative 2 point. And of course, I can divide both sides of this by 13 like we did. So 13x divided by 13 gives you x. And 39 divided by 13 is 3. Again, same line. So there's my solution for x. X is 3. And remember, we took that 3 and put it in place of x in this one. So 4 times 3 plus y equals 10. Whoops, not 120. 10. So remember, that was 12. Okay, so notice we've got this line here. It's the line actually y equals negative 2. And so we subtracted, which is the solution for y, we subtracted 12 from both sides. So when you do that, you get 12 minus 12 is just y. We just have the y term left, equals, and 10 minus the 12 was -2, and we produce another line the same as the last one. These are actually the same thing. So there's my solution. X is 3, y is -2, and that's what it's looking like graphically. Again, every time you take a multiple of some line, you produce the same line, and when you add multiples of lines together, you get another line that still goes through the same intersection point. And that's the end of the tutorial.